Welcome to our virtual lab. Today I'm going to discuss about the operational amplifier fundamentals. You might have seen operational amplifier in the earlier classes. That means in the BSc physics itself. You might have studied operational amplifier. Operational amplifier is an IC, integrated circuit. This photograph of the operational amplifier is given here. IC 741. Here it is written LM741CN. The plastic package, 8-pin plastic package. This is a operational amplifier. 741 is a integrated circuit operational amplifier. So what is an operational amplifier? Who invented the Opamp? Who designed the Opamp? So this is a person called D. Schwarzschild Jr. was the inventor of the operational amplifier. Operational amplifier is also called Opamps. He filed the patent for the summing amplifier in 1941 when working in Bell Labs. So he was an engineer, electronics engineer in the Bell Labs. While he was working there, he designed the chip called operation amplifier. It is a popular chip which can be used for many purposes. Why we got to study Opamp? Opamp finds applications in science and technology, engineering, control applications. Wherever you need industrial controls, Opamp comes there. Wherever you are having medical instruments, most instruments make use of the Opamp, operational amplifier. So there is no instrument without Opamp. All the instruments are built with some kind of Opamp. There are many Opamps in the market. One such Opamp is a 741. There are many Opamps in the market. Okay, this is a symbol for the operational amplifier, universally accepted symbol, the internationally accepted symbol. So there is a triangle. This is a triangle. Triangle represents the operation amplifier. These are the terminals, plus, minus. The two terminals, V plus marked as V minus. These two terminals are called non-inverting input and inverting input. This is an inverting input. This is called a non-inverting input. And this one is the supply voltage, Vs plus or VCC is also called VCC plus VCC, supply voltage, positive supply voltage. And the lower one represents the negative supply voltage, minus VCC. It is also known as Vs minus, supply voltage minus. So the operation amplifier works with double power supply. Double power supply is also called a dual power supply. Operation amplifier works with the dual supply. It means plus VCC and minus VCC and ground, common ground. So we need two power suppliers, one supplying the positive power and another supplying negative supply. And this terminal is a output terminal. So it is marked as a V out. This is called output voltage. It's called output voltage. So these are the basic terminals of the operation amplifier. There are also other terminals that we will see later. So these are important terminals. There are two inputs, inverting input inverting input, and non-inverting input. What do you mean by inverting input? Anything you feed here, any signal you feed here, it will be inverted and appears at the output. I am repeating, anything you feed here, anything you give as input, this will go into the Opamp, integrated circuit amplifier, and finally it will appear. Oh, let me resume here. These are the basic terminals. Inverting input. I am describing the inverting input. If anything you give here, it will appear in the inverted form at the output. So if we give a sine wave here, we give a sine wave here, the sine wave voltage, alternating voltage here. Positive cycles will appear as negative cycles in the output. Negative cycles will appear as a positive cycle at the output. This is called inversion. That means 180-degree out of phase. The signal will undergo 180-degree out of phase at the output. Output and inverting input are 180-degree out of phase. Positive cycles will appear as negative cycle. Negative cycles will appear as a positive cycle. Increasing voltage here will appear as a decreasing voltage at the output. Decreasing voltages applied here will appear as a increasing voltage at the output. That means output will be inverse of the whatever you feed here at the inverting input. This is the working of the inverting terminal. This is the action of the inverting terminal. Okay. Okay. Next, what is the non-inverting terminal? What do you mean by non-inverting terminal? Non-inverting terminal does not show inversion. Does not produce any inversion. Whatever you give here, if you give a positive pulse here, the same positive pulse will be amplified and appear as a positive pulse. If you give a negative signal here, the same negative signal will appear in the amplified form, but in the same negative fashion. So positive cycles will appear as positive cycles, negative cycles will appear as negative cycles. So the only thing is the output will be amplified, but the trend will not be changed. If the input signal is in the increasing trend, output signal will also be in the increasing trend. If the input signal is in the decreasing trend, output signal will also be in the decreasing trend. So output signal is in phase with the non-inverting input. V plus is called a non-inverting input. Non-inverting means no phase inversion. Output just follows the input. So there is no phase difference between the output signal and the non-inverted signal, non-inverting input. This is the function of the non-inverting terminal. So there are two inputs, V plus and V minus, and a single output. So every Opamp, all the Opamps, there are hundreds of Opamps in the market, hundreds of integrated operation amplifiers available in the market. We go to the electronic marts. If you ask the vendor, give me an operation amplifier, he will definitely ask back to you which number you want. So immediately you have to tell the number. So that number, there are variety of operation amplifiers available in the market. So all the Opamps are having dual input. Dual means two. There are two inputs, non-inverting input and inverting input. So there are two inputs and one output. Double-ended input, single-ended output. Double-ended input, single-ended output. This is the so let me proceed. Let me proceed to the operation amplifier basics. So operation amplifier is an integrated circuit amplifier, and it is having double-ended input. Double-ended input. There are two inputs. So because in other amplifiers, there will be only one input. But here there are two pairs of input, one pair of inputs. That means two inputs, double-ended input, single-ended output. Usually single-ended output. Double-ended output is also available. There are amplifiers with double-ended output, but here it is only single-ended. Single-ended means output should be taken with respect to this V out pin and ground. Output should be taken with respect to this V out pin and ground. So, input. In the same way, inverting input should be given with respect to ground. Non-inverting input should be given with respect to ground. Everything should be given with respect to common ground. The common reference point is called ground. Ground means 0 volt. Ground means 0 volt. Vs plus means positive voltage. It will be usually plus 12 volts. Plus 12 volts. Usually plus 12. Proceed now. Okay, I am telling about the supply voltage. Supply voltage. There are two supply voltages. Positive supply voltage and negative supply voltage. With respect to ground, you have to give positive voltage and negative voltage. There will be a common ground. The common ground is at 0 potential, 0 volts. The common ground is at 0 potential. That means this is a common reference point. All the inputs and supply voltages outputs are taken with respect to ground fault. See the slide. An operation amplifier is a DC coupled high gain electronic voltage amplifier. See the important words. DC coupled high gain electronic voltage amplifier with differential input. The V plus V minus is called a differential input. And a single-ended output. V out is a single-ended output. With a high input impedance, low output impedance, capable of doing mathematical operations such as addition, subtraction, differentiation, and integration, etc. So, this is a short definition of operation amplifier. Are you able to understand this? An operation amplifier is a DC coupled. What do you mean by DC coupled? DC means, here DC means, it is not direct current. Direct coupled. Direct coupled. DC means direct coupled. High gain. High gain means output to input ratio will be very, very high. It's called a high gain. So output will be 1 lakh times that of input. Approximately AV is equal to 1 lakh. Approximately 1 lakh to 1 million. 1 million voltage gain. AV means voltage gain. So இது ஒரு ஆபரேஷன் ஆம்பிளிஃபையர்ங்கிறது ஒரு வோல்டேஜ் ஆம்பிளிஃபையர் தான். இது எப்படிப்பட்டது அப்படின்னு கேட்டீங்கன்னா டைரக்ட் கப்புள்டு. அதான் டிசி கப்புள்டுன்னு சொல்றோம். டைரக்ட் கப்புள்டுன்னு பேரு. ஏன்னா வேரியஸ் கப்ளிங் ஸ்கீம்ஸ் எல்லாம் இருக்கு ஆம்பிளிஃபையர்ல. ஆர்சி கப்ளிங் இருக்கு, எல்சி கப்ளிங் இருக்கு, டிரான்ஸ்ஃபார்மர் கப்ளிங் இருக்கு. அதுல இது வந்து டைரக்ட் கப்ளிங். ஸோ இது வந்து டைரக்ட் கப்ளிங் கப்புள்டு ஹை கெயின். ஹை கெயின் மீன்ஸ் gain of the order of 1 lakh to 1 million. 1 lakh to 1 million. Imagine the tremendous gain. So this is a very high gain. This gain cannot be obtained in ordinary transistor amplifiers. But high gain cannot be obtained in ordinary transistor amplifiers. You must know what is amplifier. Amplifier is a device. What is amplifier? Amplifier is a device which amplifies the weak signals. Amplifier is a device which amplifies the weak signals. So this is the electronic voltage amplifier with a differential input and a single-ended output with a high input impedance. That means input impedance of amplifier will be very, very high. Impedance means input resistance. High input impedance means very high input in resistance. And low output impedance. Low output impedance means at the output side, the resistance of the circuit will be very, very low. So low output impedance. Output impedance will be low, input impedance will be high, and an amplifier is capable of doing mathematical operations such as addition, subtraction, differentiation, integration, etc. Almost all mathematical operations you are doing in algebra, vector calculus. So all the mathematical operations can be performed easily with the operation amplifier. That is, it is called operational amplifier. It's not an audio amplifier, or it is not an video amplifier. Audio amplifier amplifies only audio signals. Video amplifier amplifies video signals. Instrumentation, there is another called instrumentation amplifier, but this one is operational amplifier. It can do operations, mathematical operations. That is, it is called operational. So it can do mathematical operations such as addition, subtraction, differentiation, integration. Whatever you do in mathematics, all these can be done in electronically. All these can be performed electronically by operational. That is, it is called operational. Their name is given, operational amplifier. It can do mathematical operations, and it also has amplifying capability. Amplifying means output will be greater than the input. It's an active circuit. Output will be greater than the input. So weak signals can be amplified. So let me summarize these concepts. What is an op-amp? Operational amplifier is a direct coupled high gain. That means output to input ratio will be around 1 lakh to 1 million. Imagine the huge figure. That is 1 lakh to 1 million is a very high value, which you cannot even imagine with transistor amplifiers. Transistor amplifier gives only gain of only around 500 only. Around only just 500. But this one gives a gain of 1 lakh to 1 million high voltage gain. It's a very high voltage gain. It's an electronic voltage amplifier, fully made up of electronic circuits with a differential input. Differential input means non-inverting input, inverting input. These two are called a differential input. These two are called a differential. Differential means another meaning. There is another meaning. The difference between the two input signals is only amplified. So the difference between V plus and V minus. V plus means non-inverting pin. V minus means non-inverting pin. The difference, the mathematical difference between V plus and V minus alone is amplified. V plus alone is not amplified. V minus alone is not amplified. But the differential input, V plus minus V minus. The difference between the two inputs, V plus and V minus, and this difference is amplified, and it appears in the single-ended output. That is the meaning of this definition. And another thing, and this statement with the high input impedance, this tells you input side is having high resistance. Input side is having high resistance. What is input side? This is the input side. Left side. The left side of the triangle is called the input side. Right side of the triangle is called the output side. So between V plus and ground, the resistance between V plus and the ground is very, very high. Similarly, the resistance measured between V minus and ground is also very, very high. That means the two input terminals offers very high resistance to the flow of input signal. Input resistance high means what does it mean? Current will be very, very small. Input resistance, if input resistance is very high, current going into the input terminal will be very small. If the input resistance is very high means current flow is very, very small, negligible. So input current is very, very small, and that is the meaning of input impedance very, very high. So input side offers very high input impedance. Input side offers very high input impedance. This is the quality of the operation amplifier. Next, low output impedance. What do you mean by low output impedance? Low output impedance. Output means right hand side. Output side. So the resistance across output and ground will be very, very low. Resistance across output and ground. In other words, resistance measured between output and ground will be very, very low. This is the meaning of low output impedance. So there is a slight difference between impedance and resistance. Resistance means opposition to the flow of direct current. Resistance means opposition to the flow of direct current. Impedance means opposition offered to the flow of alternating current. Impedance means opposition offered to the flow of alternating current. So there is a slight difference between impedance and resistance. So input impedance, output impedance. Input impedance will be very high, output impedance will be very low. This is the nature of the operation amplifier. And these are the capability of the operation amplifier. Mathematical operations, all mathematical operations can be performed with the help of operation amplifier. So, I hope you understand what is operation amplifier. Operation amplifier என்னன்னு பார்த்திருக்கோம் உங்களுக்கு. ஆப்ரேஷன் ஆம்பிளிஃபையர்ங்கிறது ஒரு இன்டகிரேட்டட் சர்க்யூட். அதோடைய நேச்சர் எப்படிப்பட்டது அப்படின்னு கேட்டீங்கன்னா, டைரக்ட் கப்பிள்டு ஹை கெயின் ஆம்பிளிஃபையர். கெயின் அரௌண்ட் 1 lakh. அதுல 2 இன்புட் இருக்கும், டிஃபரன்ஷியல் இன்புட். The difference between the 2 inputs is amplified and appears at the output. அப்புறம் இதோட இன்புட் சைடு பார்த்தீங்கன்னா ஹை இன்புட் இம்பிடன்ஸ் ஆஃபர் பண்ணோம். அவுட்புட் சைடு பார்த்தீங்கன்னா லோ இன்புட் அவுட்புட் இம்பிடன்ஸ் ஆஃபர் பண்ணோம். இதுதான் நம்ம இது வரைக்கும் பார்த்துருக்கோம். தேங்க்யூ.